All right. So I posted the PDF of the answers, and this is me just walking through the answers real quick of 9.1. We should have gotten them passed out. The sub should have asked someone to help him pass it out. So hopefully we're looking at it. I looked at it real quick just to grade it, but you're looking through it to actually understand what you did and what you might have done wrong. So if we look at 19, first we have to look at this and try to figure out what's going on. So when we look at this, what we're trying to do is figure out any intervals where we're increasing or decreasing to help us figure out what type of function would be the best for our regression model. So if we look at this, we start at x equals 1, and our y value is 49. As we go all the way over, we are decreasing because our numbers are getting smaller. But that stops at 10. And as we move more, as x increases, we hit 19 where it was increasing. Between x of 5 and x of 7, our y's are increasing, and then we start decreasing again when x got bigger than 7. So if we just wanted to quickly graph this, we could pretend like we're on a graph. We were starting at 49, we were decreasing to 10, increasing to 19, and then decreasing again almost to the x-axis. So not the most perfect sketch, but we can see right away that it's starting to form a familiar shape. So the answer for number 19, what type of function could be used to model this data? We could say it's cubic. And now with some new vocab words, we can say because it has 2 turning points. Or you can say because it decreased, then it increased, and then it decreased. Or you could say it has 2 extrema. So a lot of different explanations here. But mostly you can stick it to how many intervals of increasing or decreasing it has, or how many turning points it has. So moving on to 20, it's going to ask, how do we actually find our regression model? So unfortunately, I don't have our TI-89 app on my iPad, which is how I do these notes. So instead, I'm going to use Desmos. So when we're on Desmos, we have to add a table and then add our information. So I'm just adding this table in. And we're going all the way up to 10. And then we can add our y's. So maybe over the weekend, I'll try to post a video of me using the TI-89 app I have on my computer, just so that way we know how to use it when it comes to test taking. But that again relies on us getting my graphing calculators back to me. I'm still missing those 2, and we need those back. It looks like I did something wrong here. 1, 2, 3, 4, 5, 6, 7, 8. Oh, and I forgot the 9. So if we look at our graph, we can almost see everything, but we might need to zoom out. And I'm actually going to fix the window here because it's bothering me. So as I said in the other video, I like to go just a little bit negative and a little bit above. Kind of space it out well. And then just a little bit negative and then a little bit above. And that should make it look good. So we can see again, as we said, it's going to be cubic. And on Desmos, what we need to do is we need to say our y list, so y1, and it should automatically do the sub 1. And then we need to do the tilde. So we go in, you should be able to get to it from your keyboard, but I had to click the little thing on my screen. And then we want cubic, so that means we have to do a x to the power of 3 plus b x squared plus c x plus d. So now if we do all of that, I didn't add in my ones. Right, so I need to add those in so Desmos knows what we're doing. On our calculator, though, we would just need to go to stat calc and then go down to cubic regression. But here we have to do a little bit more work. So we get here these parameters for A, B, C, and D. All right, we can round. I would usually say 2 decimal places. I don't think the book really said how far to go. So when in doubt, just go to 2. So for number 20, we get y equals, and that a value that we got from our regression was negative 0.4, and if we round to 2 decimal places, only 0, x cubed, and then we have plus 7.199, etc. But if we round that, we have to round it to 720, and that's x squared, minus 39.76x plus 80.03. So that would be our linear regression. I'm sorry, not linear regression, our cubic regression for the data points. And then for number 21, it says graph it and then list the important features. So Desmos, being Desmos, automatically did it for us, but in your graphing calculator, you would just have to actually type it in. Make sure on your graphing calculator you turn stat plot on, and then we can go to zoom stat for it to auto fit our window. If we wanted to start talking about our key features here, those we could get into a lot of information like domain range, but we're just talking here about like x-intercepts, y-intercepts, and any extrema. So looking at this, we can get all the information on Desmos. You can get the extrema by clicking it, get our x-intercept by clicking it. On your graphing calculator, you would actually have to use some of it like trace or those other features. So for 21, we are going to go over. This only had one x-intercept. So our x-intercept, aka our 0, or our root, was that x is equal to approximately 10.08. Our y-intercept would be this d value right here. Our y-intercept was equal to 80.03. And then our relative maximum, right, if we look back at our graph, we have a relative min and a relative max. So our relative maximum, and then here we're going to do our coordinate point. So it was at 7.65 and 17.62. And our relative min was at 4.32 and 10.28. All right, so on today's quiz, I'll ask you some very similar thing. Number 22, it's telling us here's a story. Try to figure out what's going on here. So an insect population doubles each month. So doubles is a very mathematical word, right? What type of function could be used to model the data for the number of insects as a function of the number of months since January 2012? Explain your reasoning. So this one, we haven't really talked about it yet because this is a function that we did not discuss. It's the next unit after this. But we can pretend. Here's one insect. The second month would be 2 because it doubled. 4, 8, 16, 32. Right? It's actually increasing at an exponential rate. So if we didn't get number 22, that's fine, because it was not within this unit that we were studying. Lastly, 23. We want to critique the reasoning of others. Jenna says that the graph on her calculator, as shown below, must represent a quadratic function. Is she correct? Explain your reasoning. So the way that it looks right now, it does look quadratic, right? We could extend it, possibly, right? Keep going up and up forever, and that would be quadratic. But because we don't see the whole window, a lot of different things could happen, right? we could have something that looks like this. And let me actually make my line thicker so we can see that a bit better against the text. We could have something that looks like this, which would be actually a like x to the fourth of some sort, right? We could have any other type of function, right? We could look like this. We just don't see the rest of our function. So the moral of the story is make sure that we can see all of our data when we graph it, when we do regression, or else you'll be choosing the wrong type of model. So make sure we do that zoom stat or zoom out on Desmos to make sure we can see all of our data, because we could just not be seeing all of the curve, all right? So that was 22, we said exponential. 23, we said it looks like it's quadratic, but it could be anything. We would need to zoom out more and see if there's more of the graph that we just can't see, because, right, this graph is pretty much zoomed in a lot, right, because we have -4, +2, -5, and 8. So we are quite zoomed in. We should zoom out a little bit just to see or check our table and see for those intervals of increasing or decreasing. So hopefully this helped. Let me write this down for the PDF. So we said it could be quadratic, right? So she is not necessarily true. Since there could be more of the function outside the visible window. All right, so on the quiz today, I'll be giving you some data to graph. You need to sketch that graph on the quiz. Then you'll need to find the regression, sketch that regression, and then kind of describe it using some of our familiar terms. All right, nothing too bad. I might start asking you a little bit from 9.2, but nothing that won't be doable for you guys, especially if we're following along with notes and we watch the other video and everything else. All right, good luck.